Assalamualaikum and hi Dr. Nura Ibn Siddiq. We are from Group 9 and we want to present about the group assignment.
Moving on to the first question. Now, I'm going to show you the tutorial on how to draw the flow curves and to obtain the value of liquid limit and plastic limit. Firstly, you have to draw the x-axis and y-axis. Second, choose a scale, determine the range, and label the axis as number of flows on x-axis and water content on y-axis. Third, plot the data referring to the data given in the question. Fourth, draw the graph and best fit straight line. Tips on how to do it is as long as the point that is not included in the best fit straight line must be balanced. Let's say 1 point above and 1 point below. Now, let's obtain the liquid limit and plastic limit value. Liquid limit value can be determined by take the standard corresponding value of water content for blue, which is 25. Then shift to the left and you will get the value of liquid limit. For my graph, I get 39.5% for my liquid limit. For plastic limit value, you can use this formula to get the correct answer. By adding the two determinations for plastic gave water contents, which are 21% and 22%, then we divide by 2. You will get 21.5% for the plastic limit value.
Next, we move to the second question from the question number 1, which is plasticity index of the soil. So, how to calculate the plasticity index? As we use the equation as shown, which is liquid limit minus plastic limit. The value of liquid limit we can get from the question number 1, which is 39.5%. And then the plastic limit we can get from the question, which is 21 plus 22 divided by 2 equal to 21.5%. So, the answer of the plasticity index of the soil is 18%.
For the last question is liquidity index if the natural water content is 28%. So, how to calculate the liquidity index? By using the liquidity index equation, is W minus PL divided by PI. Okay, in this equation, W stands for water content, PL stands for plastic limit, and PI stands for plasticity index. For W, we take the value from the question, which is 28% minus PL, which is 21.5 divided by 80%, and the answer is 0.36.
Next, we move to process of KAS4513 method. In KAS4513 method, we need water, soil, breast cup, portion of soil paste, revolution per second, and grooving tools. For introduction, the KAS4513 method is a procedure that determines liquid limit of soil, which is the water content at which transition from a plastic to a liquid state. Next, we move to the step. Step 1, we need to mix a soil sample with water to create a paste. Then, we need to put the paste in a breast cup. Step 3, we need to use a grooving tool to make a groove in the center of paste. Then, we need to drop the cup onto a hard rubber base at a standardized rate. Next, step 5, we need to count the number of drops required for the groove to close over a certain distance. Step 6, repeat the test multiply time with different water content. Lastly, calculate the water content required to close the groove in 25 drops. So, the conclusion of KAS4513 method. The KAS4513 method uses a mechanical device to standardize the blows, making the experiment more repeatable than the original liquid limit test.
Process cone pintrometer method. The introduction. The cone pintrometer method is another technique used to determine the liquid limit of soil. It involves the use of a cone-shaped pintrometer device that is inserted into the soil sample. Step 1. The picture shows is sample preparation as in the cassegrain method. The soil sample is prepared by mixing it with water to achieve the appropriate consistency. Step 2. The picture shows is the cone pintrometer is placed vertically on the ground surface. The cone is lowered into the ground with constant pressure. Step 3. The depth of penetration of the cone is measured after pressure is applied for a certain period, usually 5 seconds. This measurement was conducted at several different moisture content levels. Step 4. Data on penetration, depth and water content are recorded. The flow curve is drawn to determine the liquid limit based on the obtained data. The conclusion. Both methods provide different ways to determine the liquid limit of soil, and the choice of method depends on the specific requirement and the type of soil being tested.